Hi everyone, this is video instruction for lab 3.4.3 in physics, circuit building. So in this lab, you are going to be using an animation or simulation that Apex provides and just some graph paper to draw some of the circuits that you are building. The exploring further materials you will not need since you will not be doing the exploring further. Okay, so this lab actually has many parts. I'm going to scroll down really quick to show you all the way to the end. You're doing 10 parts, okay, but they're not difficult. And then you've got some analysis and some conclusion questions to answer. So all I'm going to do today is just walk you through how you're going to collect your data, all right? So essentially, if we come down and look at the procedure, Part 1 says, design a circuit that has two resistors connected in series, okay? Given that you have a 20-volt battery, choose resistors that will produce a current of 0.2 amps, all right? So you're going to be using the simulator that they provide for you here. And I was just playing around with it, so let me clear it. So this is what you're going to see when you open up the simulator, all right? It says in your lab you want oops, wrong page. It says you want two resistors connected in series to a 20-volt battery, all right? So if we look at what we are given here, this is your resistor. You can change the resistance of the resistor. It goes as low as 20, okay, but it can go higher. And the voltage of the battery can go lower and it can also go higher. So that's how you change that. Down here, you have some other simulator options. You can change the number of resistors by going up or down. So if I click to the right, it'll add a resistor for me. And I can change from series circuit to parallel circuit. Okay, so those are your options there. Now, this blue box here measures the current. The ammeter measures the current. So all you're going to do is drag this blue A anywhere you want it. When it highlights red, then it will read the current in that location in the wire. Okay, the plus and minus you have to put on opposite sides of a resistor or the battery for you to get the voltage. So this is the voltmeter. So if I put the minus there and I put the plus on this side, it measures the voltage of the battery to be 10 volts, which is correct, okay? But you want to measure your values. You don't want to just read what's on the screen, okay? Make sure you measure. You can't measure the resistance. You have to trust that these are the resistances, but you can measure the current and you can measure the voltage, okay? Now, sometimes it will tell you to measure the voltage at the resistor, okay? So to measure the voltage at the resistor, you're going to just drag a positive and a negative until it highlights red, all right? And so this gives me the voltage. Ignore the negative, it just means the positive and negative are flipped, but the value doesn't change. So this tells me that the voltage of this resistor is 5 volts, all right? And you can do the same thing for the other one. Here's the negative, here's the positive. I put it on either side of the resistor and it gives me the voltage of that resistor. Okay, so that's how you use the ammeter and the voltmeter for this simulation. Okay, so if we go back to your lab, you're going to use the flash animation. You're going to build the two resistor circuit, and you want to build a circuit where the current is 0.2 amps and the voltage is 20, right? So you need to change the voltage to 20. And let's say we leave these at 20, right? If I measure the current, it's 0.5 amps, okay? But in my lab, it says I need it to be 0.2 amps. So you're going to need to change the resistances so that you can get the current to be 0.2 amps. Now, you can do this by trial and error, which will probably take you a while, or you can actually do a calculation using Ohm's law, V equals IR, which you learned in this unit, to figure out what the resistances should be in order for you to get a current of 0.2. Okay? So you would say V is 20, I is 0.2, V equals IR. You divide them, you get a number, and then you're going to have to split that in half because you have two resistances here. And so you'll continue to do that over and over again with different challenges. Okay, so for example, part 2 says design a circuit that has two resistors connected in parallel. All right, here's the voltage they want you to use. Here's the current they want you to get. So you'll have to figure out what resistances should those two resistors in parallel have in order for me to get a 1.5 amp current. Okay, so you'll go here, you'll say I want parallel, and I want one resistor in each loop. All right, it tells me that I want the voltage to be 20, so I'm going to leave that, and then I'm going to measure my current. My current here reads 1 amp. My current here also reads 1 amp. So if I go back to my lab, I need my current to be 1.5 amps. So what should I change the resistance to get it to be 1.5 amps? Again, you can do a calculation or you can try trial and error. Okay? And then you're going to follow along. Like you're going to need to fill out your data here, draw your circuit, all that good stuff. All right? Part 3, you want a single resistor in series. This time they tell you what the resistance should be. They tell you what the current should be. You have to figure out what should the voltage be. Okay? So what should I make the voltage so that my 100 ohm resistor has 0.4 amps of current? And you'll go back and you'll do that again here. All right? Single. It was 100 ohms, right? So we're going to move this up to 100 ohms. And we're trying to figure out what voltage will give me 0.4 amps. So if I just leave this on 20 volts, what will my amps be? They will be 0.2. I need 0.4. Okay, so you're going to do the math and figure out what you should be changing there. And then it just goes on and on with various different challenges to get you to do some calculation. So you're going to calculate the voltage, you're going to put in the experimental voltage you used, you're going to calculate the current, you're going to put in the experimental current that you used. Okay, and that will go all the way down to step 8 or part 8, part 9. Just has you comparing what happens if you open the switch, okay? So you're going to be measuring current and voltage with the switch on and then with the switch off, okay? Off and on. And answering some questions there. Part 10, design a simple circuit using one light bulb and instructions from step 1. Use the 20 volts. Use the ammeter to determine the total current in the circuit as an indication of its use of power, right? So we're talking about power here. And power, remember, is equal to current times voltage. Yeah, so the exploring further you're not going to do, but you will have some conclusion questions to answer and you will have some analysis questions to answer, okay? This should not give you that much trouble. If you do have questions, please shoot me an email. I'm happy to jump on a Zoom and we can work through it together. Okay? Have a great day.